I am the founder, co-creator of the Forgotten Runes Wizards Cult. This contest bug bounty is for the Forgotten Runes Warriors Guild. So just a little bit of context, it's for an NFT project. So we already have the set of NFTs, the Forgotten Runes Wizards Cult. And so these would be some of the wizard NFTs that we've minted already, and we are doing a new series, which is the Forgotten Runes Warriors Guild. So this contest and this video is about the contracts for the Forgotten Runes Warriors Guild minting experience. So there is a $30,000 total award pot, and you can see the contest details here. So what I'm going to do right now is I'm going to just go through the README, kind of explain the code to you, explain some of my thinking, and over the next few minutes, we'll just talk through the code, and I'm going to give you kind of a tour as if you're a programmer sitting here next to me, and I was explaining to you, saying, here's how it works, here's how the infrastructure works, here's what I expect to happen, and here are some of the areas that I'm concerned about. So yeah, let's just settle in, and we'll talk through it a little bit. So this, here are some links about us. You can find our website, our Twitter, our Discord. You can contact me on Twitter. I am Dota, or also on Discord, Dota0001. And for the scope, we're looking at the files in the contracts folder. Particularly, we're looking at the two contracts, which would be the Warriors Guild and then the Minter contract. There's a couple other testing contracts and some interfaces, but you don't really need to worry too much about those. I've also written test suites for these using like Hardhat, and I guess it's Mocha. And I'm not going to be going over those in this video, but of course you can see them to kind of see the things that I've tested so far. And if it's helpful for you for sort of seeing how it's done, feel free to add your own tests if that's something you feel like doing. So, okay, so the Forgotten Runes Warriors Guild is going to be an ERC 721 token. The max supply is 16,000, and it's going to be minted in 4 phases. I've actually created a graphic here. Let me pull that up. This is a bigger graphic, and you notice it just has the first 3 phases, and let's go through it. So the first phase is a last price Dutch auction phase, right? So it's a true last price Dutch auction. Everybody pays the same price. They're at the end, by the way. So we're just auctioning off 8,000 warriors. It'll be a 24-hour period on May 11th. So today, as I'm recording this, it is April 28th, 2022, and we're going to release it. We're going to start this auction in about 12 days on May 11th. The mint is going to start at 2.5 ETH and drop by 0.05 every 10 minutes until it reaches the, let's say, floor price of 0.6 ETH. Then after this phase ends, we're going to send refunds to whatever was paid above the final price. So everybody pays the same price for all paid phases of this auction. So it's not a case where, for example, if you pay 2.5 up front, you're just out 2.5 if the auction drops. No, everyone pays the same price. But the refund happens after phase 1. We'll talk about that in a little bit. Phase 2 is the next day. So it'll be 24 hours later, and it's the mint list phase. So this is for folks on the mint list only. And, we'll be creating kind of the mint list internally. It's for, half of the people are people who are wizard holders already, and half of the people are people who qualify for a mint list through various means. But effectively, from the contract perspective, it's just a Merkle tree. And there's a certain number available for the mint list phase. And in the mint list phase, everyone will have 24 hours to mint a single warrior. So there'll be exactly the same number of people on the Merkle trees as there is supply available. But this is a paid phase. Even if you're on this allow list, you still pay whatever the final price of the Dutch auction was. And then phase 3 is the public phase. Presumably because it's a 24-hour period, everyone on the mint list has 24 hours. It's reserved for them. Maybe, for example, they say, it's 0.7 and I was expecting 0.6 and they don't want to buy for whatever reason. And so then there will probably be some left over, and then the public phase. And so hopefully we avoid too much of a gas war in the Dutch auction phase. We'll see. And we for sure will avoid a gas war in the mintless phase. But the public phase probably will have a gas war, right? And so this is the third final phase of the sale for all remaining warriors that weren't sold. And this again, if this is on Wednesday, Thursday, Friday, it's 24 hours after the mint list. And again, it's using the same price. Now, there's actually a fourth phase that's not actually listed in this diagram. And the fourth phase is basically the free claim phase. So for our project, we have what we call the Book of Lore, where people write lore and stories and make images about their characters. And anyone who wrote lore before the snapshot date will be able to claim a free mint of the warrior. Now, again, from the contractor perspective, there's just simply a Merkle tree and then a max supply that we have to account for. But that's the kind of fourth phase. So these, there's a longer explanation of the mint in a blog post, which I've linked to here. You can read it where you can kind of see the expectations. And really, like, when I think about, like, at a high level of the goal of this kind of code review, the goal is really, like, make sure everyone gets the tokens that they're entitled to at the correct price, and then everyone gets the refunds that they're entitled to, and that the team gets the money that they're entitled to, right? And making sure that kind of all of those things are aligned across all the phases, across the pricing, and particularly across the refunds, right? So there are two contracts. One is the ERC 720 token. It's quite short. It's only about 80 lines of code. Try to keep that very minimal. And then there is a minter contract, which is basically where the complexity is. It's the minter that has the permission to mint within the ERC 721 token. So this section right here is basically me explaining what we went over above of the different phases in the diagram, just kind of spelled out. So to dive a little bit deeper into the supply breakdown, there is a supply of 16,000 warriors. And in phase one, there's a Dutch auction. So there's actually four functions. A function bid summon for bidding in the Dutch auction, a function mint list summon for minting in the phase 2 mint list, public summon for minting in phase 3, and then the claim summon for the free claim in phase 4. And so here is a way that we're relating kind of the supply breakdown to what functions that goes to. So the Dutch auction, the 8,000, go to the bid summon function. The holders and the allow list folks, right, there's one Merkle tree, go to mint list summon, and there's a supply of, roughly 6,200. This final number will probably adjust to something very specific by the day of mint. We have to kind of just see how many people apply to the mint list, that sort of thing. And then public summon will be the remaining up to a cap, right? Because some of them are free, so we need to make sure we have enough for free. So we'll go over the code of how that is implemented. And then there's basically the claims phase, right? So the lore writers go through claim summon at a particular time, and then the team is donating 333 to our community DAO. We're minting about, this says 325. I think it'll be a little bit higher for the team and partners, probably be about the same, 333. And then we have about 50s for honoraries and contests and things like that. So we basically will have to kind of, these numbers are configurable in the contract because of the fact that they'll be like dialed into a final number before the day of mint. Okay, so we'll take a look at the individual lines of code of the contract in a second. The Warriors Guild ERC 721 is actually relatively straightforward, and it's actually the minter that is a little bit more involved. So here's like a timeline of when these various methods can be called, right? Bid summon in the beginning, then the mint list, then the public, then the claim. And so these lines are kind of indicating the fact that, you could call the mint list summon during the public summon phase, but there's not really an advantage to it because sort of like the mint list supply actually rolls in to the public supply phase. And similarly, once the public sale, like once this timeline is kind of run, it is possible for people to do a free claim while the public sale is still going, right? In the case that we sell out very slowly, maybe you turn on the claim sale, the claims while the public sale is running, so for example. And the team actually can mint at any time, short of any bugs that you may find. the team should be able to mint at any time without confusing any of the other phases. In the configuration, there will be a function called set phase times, and that's one of the things that we'll have to do to set up properly. Also, as we get into it, you'll notice that there are some functions that require admin rights, like only owner. So myself, and my partners own the keys that control these only owner functions, and there is maybe a degree of like centralization to these functions. Okay, so insofar as like the fact that we own those keys, and there's a bit of maybe not centralization, but in terms of like trust assumptions is I guess what I'm saying. The Dutch auction pricing will start at 2.5 and then at 0.6 and descends by 0.05 every 10 minutes. These parameters are configurable. We're unlikely to change them, but one of the reasons they are configurable is like, let's say, for example, it overwhelms our expectations and the site gets like, taken down because it's too popular or there's some sort of attack or something. We wouldn't want, for example, for the timer to run down on the pricing and then the site comes back up and the pricing is super low, and we just sort of like we miss out on the higher price demand as a team because of some sort of like technical issue with the website. So these variables are configurable. Presumably, if that sort of situation were to happen, we would pause the contract, we would adjust the times, communicate with the community. Once everything sort of seems like it's back in order, we would kind of bring it back up. Another thing that's like very important kind of in this process is the idea for the refunds on the Dutch auction. I'll get into the code and show you, but our plan actually is that we as the owners will be issuing the refunds directly after phase 1. And I realize this will be somewhat expensive, right? It might cost maybe 10 to 20 ETH. But to me, it's really the refund portion that's maybe like the most kind of, I don't know, that gives me the most pause or feels like the biggest surface area for attack, right? Which is like, well, if I was a hacker, this would be the part that I'd be looking at is how can I take advantage and exploit of the refund process. And so we actually don't allow people to do self refunds in the beginning, where the team will actually issue the refunds at first. And we'll work on, and there is a function, which we'll talk about in a minute, for self refunds. And I'm actually going to set that timer for when self refunds can happen to maybe a week after mint, right? Because ideally, I will be issuing the refunds to folks the first day of mint, and people will not have to refund themselves. But in the case that I don't know, something horrible happens to me and I'm not, physically able to issue the refunds, there's at least kind of this like emergency sort of withdraw function for refunds for minters. Another thing that's important to understand is that, we actually, as the owners, have the ability to withdraw all of the funds at any time, right? And this shouldn't break anything in the mint, but it does present maybe like a trust risk insofar as like the minters have to trust us that we're not going to withdraw the money that they would have been owed a refund. Our community trusts us. They know us. We've been around for nearly a year now. And our company is like a legal U.S. registered entity. And so, we're effectively doxed at a legal level, if maybe not to the community. So I think basically what I'm saying is I'm comfortable keeping this ability for us to withdraw the funds at any time. And whatever, we won't steal the money. To me, that feels like a better alternative than ending up in a world where there's some sort of problem with the contract and we're unable to withdraw the funds like we've seen in some sort of recent Dutch auctions. One of my questions here is maybe can we lower the cost of issuing the refunds? I'm not sure. And I think, of course, like, is the refund logic correct as you see it? I think we need to know. And when we issue refunds, we actually wrap the ETH in WETH and we send that instead. Okay. So here are some of my areas of concern as we go into this code. 1, withdrawing funds. Is there any scenario where the team can't withdraw the funds? It seems to me that if something goes horribly wrong, at least if we can withdraw the funds, then we can kind of make it right. And if the funds get stuck, that's sort of this like nuclear problem. Looking at refunds, issuing refunds, do you see that the logic is correct? Do you have any suggestions on how we can save gas? For self-refunds, do you see any bugs in ways that people could claim more than they're entitled to? And then next would be the phase supplies. Is there any sort of issue with the supply in any of the phases? And then the Dutch auction price calculations. Do you see any like problems? Do you feel like the pricing is accurate within the phases of the Dutch auction? So there's some known configuration, right? Like we have to configure the times correctly. And also one of the things that you'll see in here is um, the final price of the Dutch auction propagates out to the future phases. And what you'll see in the code is I'm not setting that final price on every mint in the Dutch auction just as a reason to save gas. I'm making an optimistic assumption that says we're going to sell out our Dutch auction phase. And if we do sell out of our Dutch auction phase, that final price will be set automatically. But if we don't sell out of our Dutch auction, then lowering the price to the 0.6 price will need to happen manually. And so that's something you'll see in here. All right. So let's get to the nitty gritty development and testing, right? Install node, install yarn, do yarn install, and you can run it. There are commands to compile, test. You can run individual tests. I have installed NodeMon here if you want to do testing with reloading. And you can get the test coverage and testing gas. So it's really straightforward, hard hat, yarn, all those things. Okay. So let's dive into the code itself. We're going to run through each of the code files, and then I think we'll be done. So let's look at the NFT contract. It's relatively okay. So here is the Warriors Guild contract. It's ownable, reentrancy guard, ERC 721. We have the number of warriors, and we keep track of the number of minted and the address of the contract or the account that's able to mint tokens, and we keep the base token URI. We typically put a little bit of lore within all of our contracts, and that's what this is. And then we'll also store a metadata hash for the provenance of the collection because it helps everyone feel that sort of the collection is solid, known, trusted beforehand. But of course, it starts on set because we haven't finalized the collection. In the constructor, we create these, set the base URI and initialize an ERC 721. I've also got this function initialize, which is a pattern I like to do, which lets me know kind of everything that needs to be set sort of after the constructor, right? Because actually the ERC 721 and the minter reference each other. And so the way that this works is you deploy the ERC 721, you deploy the minter, and then we set the ERC 721 minter for this to work. Token URI, straightforward, just appends the token ID to the base URI. We check here's a convenience function to check if the token exists. And then when we mint, so the minting function is relatively straightforward. We just say, okay, mint one token, and here's the recipient. We check to make sure that you don't summon more than the max amount, and we verify that you are the minter account before we let you mint. We set the token ID to be the number that have been minted already. So this starts at 0 and should be less than 16,000. We call a safe mint over to the recipient with the token ID. So of course with safe mint, that means that the receiving address needs to either be kind of like an end user account or a contract that implements, on ERC 721 received. We increment the number minted, and we'll return the token ID in case you want to use that downstream. These tokens can be burned, so here is a convenient burn function that requires that you're approved or owner. And then we have some functions for only owner. So setting the base URI, setting the minter address, setting the provenance hash. And then these two functions are funny if you haven't looked at how to store on-chain images and data before. We do this with the wizards as well. But there's an empty function, and what this basically does is it allows us to, what we do is we encode the images and the attributes. And then we call this function as the owner. And it lets, because ETH stores the call data on-chain forever, there's basically a way to always recover the images and the attributes of these NFTs forever from the Ethereum blockchain. So if you want to learn more about that and how it works, you can read the blog post that I wrote about the on-chain encoding. We did this for Wizards. We're doing it for Warriors too. And then just a couple little functions, right? So one is the withdraw all for any ETH that gets sent here by accident. So again, the minter is a different contract than this. So no one should be sending ETH to this contract, but if they do, we can take it out. Similarly with ERC20s is if someone sends their ERC20 to this contract, you actually send USDC or WETH or whatever, we want to be able to withdraw it. This is just a way to help our users who maybe get confused. Okay, so yeah, that is the ERC 721, a Forgotten Warriors Guild. Let's hop over to the Minter, which is kind of like the bigger one of the crew. So the Minter is ownable, pausable, and has a reentrancy guard. We start off the contract by keeping track of basically 5 times: the time that this Dutch auction starts, the time that the mint list phase starts, the time that the public sale starts, the time that you can claim free ones, and then the time for self refunds. So we set this to, the max integer, so that way this is, so far in the future, it can't happen until we set it, right? If we set these to 0, then all these things would be on the moment we deployed it. Then we set up the Merkle roots for the allow list phase. I actually set up 2, mint list 1 and mint list 2. Why do we have a backup? Well, because when you change the Merkle tree, of course, you also have to update the proofs on the front end. And, there might come a case where there's sort of a lot going on in the moment where we're minting and we found out something wrong, or we want to add someone to the list. By having 2 actually and checking within this contract, it allows us to atomically upgrade the mint list. And so it's something that we've needed in the past, and it's like very handy. So we have mint list 1 and mint list 2, so that way we can atomically upgrade without sort of any service interruption. We don't have to take down the website or whatever to upgrade the list. We also have a Merkle root for the claims list. We have a Merkle root for the claims list. So these would be the free mints. So the mint list is actually paid. The claims list is free. We keep the address of the Warriors contract, and then we also have an interface which allows us to mint from that contract. We keep the address of a vault. The vault is basically a address to where we will send the funds. So, for example, we probably will send the funds to a different address at different times, and this lets us kind of control that. We also keep the address of the WETH contract, or the WETH contract. And the reason we do that is because when we issue a refund, if you have some sort of griefing contract that tries to reject us sending you the ETH, that's fine. We're just going to wrap it in WETH and send you WETH instead. Here we keep the start price of the Dutch auction as well as the lowest price of the Dutch auction, and the price curve length in 380 minutes, and the drop interval is every 10 minutes. So every 10 minutes is when the price steps down. We also keep this variable, which is the final price of the Dutch auction. So again, this is used for subsequent phases. After the Dutch auction is finished, we set it high, so that way it sort of, defaults high. And then when the Dutch auction sells out, this number will be updated. And because of our optimistic assumptions, if we don't sell out the Dutch auction, this will have to be set manually for the pricing to be accurate in the subsequent phases. Okay, how we keep track of refunds. I almost wonder if the refund logic is maybe easier to look at than these state variables. Well, whatever. Well, this is how we'll do it. Every time someone mints in the Dutch auction, we push that address onto this list of Dutch auction minters, DA minters. And what this basically lets me do is when it comes time to send a refunds, I enumerate over this list. And we enumerate over this list and issue a refund for each address. And you might say, Dota, that's crazy because the same person is going to mint more than once, so you'll get duplicates. And, it's cost me gas in issuing refunds, but it's not that big of a deal because we check and see how much refund that person is still owed. And so it costs us a little bit gas up front. It costs us a little bit gas on the backside to issue refunds, but to me, it's not that big of a deal. In terms of with a supply of 8,000, our worst case scenario is 8,000 minters. I expect the real number is going to be closer to 3,000 to 5,000 unique accounts would be minting. I expect it to be probably 3,000 to be honest. So these this keeps track of the number of all of the addresses that minted, every transaction really. And then we also track the total amount paid by any given address into the Dutch auction, right? So if I come to the Dutch auction and I've bought, I paid 2.5 ETH, and then I paid 2 ETH, and then I paid 1 ETH, and I ordered one each time, we'll add on how much you paid onto this mapping. And then we'll also add on how the number that you minted, the count, so in that previous case, I minted, say, 3. So we'll have the total amount paid and the total amount minted. And so then when it comes time to issue a refund, we'll find, the price that you owed, which is the final price times the number that you minted. And we'll subtract that from the amount you paid to get the amount that you should be refunded. And then we save that in Dutch auction amount refunded. Okay, so you can confirm that logic a little bit further down. Next, we want to track if a given address minted in the mint list. You can't mint twice with the same address. It's one per account. And similarly with the claims list, we check that you claimed once and you can't claim a second time. The total number of supplies reserved for the Dutch auction phase is 8,000. We track the total number of sold versus freebies. So this would be sold in any phase, right? Sold in the Dutch auction, sold in the allow list, sold in the public phase, right? So these aren't freebies, but these are the max sold. And the maximum amount for sale is, 14,190. Again, this is configurable. We track the number that are claimed for free. And we also keep a hard cap on the number that can be claimed for free, again, configurable, right? So between, even these kind of added together, you'll notice that we don't keep the, we're not tracking the number that the team can mint. Effectively, the team can mint any supply that's left over out of the 16,000. And presumably the ERC 721 contract will enforce the 16,000 cap overall. Okay, here's in the constructor, we pass in the warriors, the WETH address, and we set the vault address to the initial sender. Here again is our chart of the different things that can be done in each phase. We start off, there are 5 summon functions. The way this is laid out is there are 5 summon functions, which we'll walk through. Then there is the Dutch auction pricing, which I suppose we'll do as we go cover the Dutch auction. Some functions that help us know if something started, and then the refund issuing section, and a bunch of configuration stuff for the owner. Well, I guess we might as well just walk through it. You can skip ahead if you decide you're sick of listening to me talk. So in bid summon is one of the more complicated parts, right? Because this is the Dutch auction. So is the number of sold less than the max supply, than what we sold out? Are you trying to mint more warriors? Like maybe we didn't mint the max supply already, but you don't want to be able to go past the end, right? So we check that there's enough supply remaining. I'm checking these things up top because what always happens, of course, in sort of mints that get popular is they sell out, and then all the people at the end kind of get this failed transaction, and it costs them a lot of gas if you put it towards the end. And so the idea is that that's the most common error for people. Let's put that check right up top, and then hopefully we save some gas is the idea. You can't mint more than 20 warriors at a time. We check the current Dutch auction price, and we make sure that the value that you're sending is more than the current price times the number of warriors that you are trying to mint. This does allow unbounded sending of ETH. Maybe there's some sort of silly games people can play. I'm not really sure there. But hopefully because of the fact that we can withdraw all the ETH, that will deter people from doing it. But hopefully there's just not any bugs. So we add the message sender onto minters. We add the amount that they paid. And we also add the number that they minted of warriors. And then we increment the number of warriors sold. Okay, so this is the part that I was mentioning, which is if the number of sold equals the maximum supply, then this is where we set the final price to be equal to whatever the current Dutch auction price is. And again, this is an optimistic assumption because of the fact that this final price is used in downstream functions. And if we don't sell out, by default it's 2.5, and then we need to set it down to where it needs to be. Maybe we could set it to 0.6 by default, but I don't know. I like having it start higher, and then we can manually lower it if need be. So then we iterate over the number of warriors that you have purchased, and we will mint and send it to the sender. Let's hop down for a second and look at the current Dutch auction price function. So if the Dutch auction hasn't started, you get the start price. If the block timestamp is higher than the start time plus the price curve length, then you get the lowest price. This is the back end of the curve. We calculate the drop per step. This function, I could go over each thing, but actually verifying this and finding a bug, if any exists, is maybe one of the main things of the contest, so please kick the tires on this function and try to find any bugs. Okay, so that is basically the Dutch auction phase. The important thing being that we push on the amount that you paid. In fact, let's hop to the refunds now and take a look at it. We're just going to hop over to refunds before we do the next phases. So the refund address function. Well, let's look at this. Issue refunds go from start index to end index, and refund from the DA minters array that address. So again, those addresses are going to have the same address more than once, but we check for that. And if you have a better suggestion for how to keep the total list of people that we need to refund, I'm all ears. But what we're doing here is we're going from the start to the end, inclusive. We're looping over. This is only owner, non-reentrant, and we're going to refund the address. When we refund the address, we calculate the amount owed. If the amount owed is greater than 0, we save how much we are refunding them, and then we call a safe transfer with fallback to the minter, how much is owed. So the refund owed is, first off, let's calculate the total cost of your mints, the final price times the number that you minted in the Dutch auction. And the refunds that we've paid you already are the amount refunded for you, the minter. So your refund owed is the amount you paid minus what you owed, your total cost owed, minus the refunds paid already, right? So what you paid minus what you owed, because we get to keep that, minus the refunds that we already paid you is the refund that we owe you. So is that wrong? Let me know. Then what we do is we call safe transfer ETH with fallback. So what this does is it does a safe transfer of ETH, right here, passing 30,000 gas, sending the value. And if that fails, we reach out to WETH, we deposit, we wrap the WETH, and then we send that WETH over to the account that is rejecting the ETH. So that's how we do our refunds. So even in the case that we have some sort of griefer in the middle of this iteration, we send them WETH, and if for any reason we need to skip over someone, we can calculate this when we do this. Okay, but let's say that we want people to issue their own refund. We have this self-refund function, non-reentrant, and we say, okay, first, did the self-refund period start or not? And then second, we just call refund address for that same sender. So presumably, I actually think that this function should work at any time, right? Like even during, I even think this function would work during the Dutch auction. Like while the Dutch auction is live, but I gotta tell you, that just makes me nervous. That just makes me feel like, I don't know, that there might be something I'm missing. So, so I'm waiting until after phase 1 is over and I'll issue it myself. I don't mind paying the ETH for kind of like that level of protection. And presumably we'll go through all of the refunds and that will be that. Okay. So, yeah, and we check to make sure that the mint list phase hasn't already started, because if it has, then the auction is over. Okay. So, all right, next up, mint list. There's a Merkle proof. We check that we haven't sold out. This actually shouldn't happen, right? Because we need to send the right number of like Merkle. We're trying not to oversell what's in the allow list, but whatever. We should check for it here anyway, in case there's a mistake. Check that the mint list phase started. Check that you sent the exact amount of ETH. Check that you didn't mint already, and then save that you did. And then we need to verify the mint list Merkle. So we're basically the leaf node is the message sender, and we verify the proof in both. First in the first Merkle root, and then it'll like run. Otherwise, we check both. Otherwise, you get an invalid proof. Increment the number sold, and then we mint. It's actually probably easier to skip over to the claim summon, as it's quite similar, right? There's a Merkle proof. Check that the number claimed is not more than the max claimed. Claim started. You didn't already claim. We verify the Merkle proof. There's not a secondary claims Merkle proof because sort of the the free claims list is not sort of kind of as like urgent. It's not going to be as much of a mad rush as I think the allow list claims will be. And so we have some time to kind of update those, and people are a little bit more forgiving because these are like our inner community that even get these. So the number of claimed is +1. We mint. Okay, the public summon says, okay, check that we have more for sale, that there's enough remaining, right? Because you can set the number of warriors. Check that the public sale started. You're not minting more than 20. You sent the exact amount of ETH. Increment the number sold. Loop over the number sold and mint 1 per. And then for the team, we can say who we want to send it to. And we can also set the number that we want to mint. Only owner. The mint function, by the way, just calls out to warriors and it calls mint. Easy peasy. So there's a couple convenience functions here for when the different times have started. The number of minters helps us have a function that kind of iterates over that. We talked about issuing refunds already. And then there's a bunch of functions by owner. Pause, unpause, setting the times, the mint list start times, all the times. Setting the Merkle roots, setting the vault addresses, warrior, WETH addresses, the start price, the DA price curves. All of these things I've left configurable because I like having the ability to kind of change things mid-flight, though I do recognize that kind of improper configuration in those could certainly lead to undesired behavior. Hopefully none of those things cause the auction to fail or get into an unfixable state, or for like the funds to be locked. And then so we have withdraw, the amount the team can withdraw to the vault, an arbitrary amount at any time. And we can also withdraw all the funds to the vault at any time. Again, there's some sort of trust that's happening here, but at the same time, they're very simple. And as long as you can set the vault, then you can take the money out, which means you can make anything right. And similarly as the previous contract, no ERC20 should be sent to this contract, but if they end up there, this lets us take them out. Okay. All right. Whew. I don't even know how long this video has been. So there we go. That is the contest. So I am available on Discord. I'm available to chat. If you find anything that is wrong with this, please let me know. I'll be super, super grateful. Thank you for your time, and happy hunting.